Welcome to the meadow map. To determine how far it is across a garden plot or a rabbit burrow, we follow a specific process. First, we picture the land, then we measure it. The Pythagorean Theorem is the mathematical rule used to calculate these distances by looking at the relationship between the sides of a right triangle. By applying this theorem, you can find unknown lengths across the meadow and use those measurements to solve complex problems in two-dimensional space. The first step is always locating the right angle. Once you find it, look directly across from it. That opposite side is always the longest side, known as the hypotenuse. The math is based on a specific balance. If you take the squares of the two shorter legs, labeled A and B, and add them together, they will exactly equal the square of the hypotenuse, C. This gives us the equation, a squared plus b squared equals c squared. This rule never changes. The hypotenuse is always the longest side, and you will always find it exactly opposite the right angle. Let's apply this logic. A fox is pacing the edges of its territory, where the two legs of its path are 6 units and 8 units long. The diagonal shortcut, our hypotenuse, is the unknown value. Since the missing piece is the hypotenuse, we add the squares of the legs. The equation is 6 squared plus 8 squared equals c squared. That results in 36 plus 64, which equals 100. It is important to remember that 100 is the value of c squared, not the length of the path. To find the actual distance, c, we take the square root of 100, giving us a final length of 10 units. When you are looking for the longest side, adding the squares of the two shorter legs provides the total you need to find the hypotenuse. Now, consider a different scenario. A turtle is crossing a diagonal stepping stone hypotenuse that we already know is 13 inches long. One leg along the bank is 5 inches, but the other leg, B, is missing. We have to change our approach here because we already have the longest side. Since 13 is the maximum boundary of this triangle, adding the squares would result in a missing side that is longer than the hypotenuse, which is impossible. Think about how you might set up this equation differently. Pause the video and try to determine the first step for finding a missing leg. Since we know the hypotenuse is the total, we work backward by subtracting. We subtract the square of the known leg from the square of the hypotenuse. 13 squared minus 5 squared is 169 minus 25, which is 144. The square root shows our missing leg is 12 inches. When a shorter leg is missing, the hypotenuse square acts as the total being split between two legs, which is why we subtract. Look at this ladder resting against a garden wall. It reaches 8 feet up the wall, and its base sits 6 feet away from the stones. We can find the length of the ladder by identifying the right triangle in this scene. The wall and the floor meet at a 90-degree angle, which identifies them as the A and B legs. Because the ladder leans directly across from that right angle, it is our hypotenuse. We add the squares of the legs. 6 squared plus 8 squared equals 100. The square root of 100 is 10, so the ladder is exactly 10 feet long. Solving a real-world problem depends on correctly identifying which physical objects represent the legs and which represents the hypotenuse. You now have 3 rules for these problems. First, locate the hypotenuse by looking across from the right angle. Second, add the squares to find a missing hypotenuse. Third, subtract from the hypotenuse square to find a missing leg. In every geometric problem you encounter, remember the mantra: picture it, then measure it. Mastering these steps provides the foundation you need for calculating distance and moving forward into high school geometry.